in this problem, we're given n rolls of a fair die, so we have n rolls. And we'd like to know what is the probability that at least one of the 6 values does not appear. So let's make a definition. Let's say let AI be the event that the value I is never seen. Is never, let's say, rolled. And so the probability we're interested in is the union from 1 to 6 of these AIs. So the probability of the event that either the value 1 is never seen, or the value 2 is never seen, or 3 is never seen, or 4 is never seen, that union is the same as saying at least one of the values is never seen. So we know from the reading that to compute the probability of a union, we can use inclusion-exclusion. And so using the formula of inclusion-exclusion, we get that the probability of the union from 1 to 6 of AI is the sum from 1 to 6 of probability of each of these events minus the sum of the probabilities of pairwise intersections. Let's say ij here, and we're going to look at the pairwise intersections. Then we're going to add in the triplets, the probability of the triple intersection. Aj, ak. Then we're going to subtract off the probability of quadruple intersections. So you can say I, j, k, w. So probability of this intersection here. And then finally, we're going to add on the probability of 5 intersections of these events. So I, j, k, w, z. And we're going to add on probability of ai intersect aj intersect ak intersect aw intersect az. Now notice that we don't have I don't add the term here where we look at the probability of intersection of 6 events, because recall that each one of these events says that the value I, so for example, this first event says the value I does not occur. The second event here says the value j doesn't occur. The value k doesn't occur. If I use all 6 of these events, that means none of the values of the die occur when we roll the die n times, and that is not possible. The die has to land on at least one value. So the probability of the intersection of 6 such events would be 0, because again the die has to land on something. So now let's compute each of these probabilities so that we can plug them into this formula. So the probability of an event AI is well, if our out of our n rolls, if the die cannot land on I, then for each roll the die has 5 choices of what it can land on, and we have n such rolls, so that's 5 to the nth power, out of a total of 6 choices of what the die can land on to the nth power. Now, when looking at intersections, pairwise intersections, if the die isn't allowed to land on I or j, then the die has 4 choices on what it can land on, and there are n rolls, so 4 to the nth power, 4 choices for each roll out of 6 to the n. Similarly, if we're looking at triple intersections, we have 3 choices. Quadruple intersections give us 2 choices. And finally, if we look at intersection of 5 of these events, let's call this AZ, this means that for all the n rolls, the die has only one value it can roll on. So that's 1 out of 6 to the n. And just to make the point clear, if we were to look at the probability of the intersection of all 6 of these events, then this probability has to be 0, because for every roll of the die has to land on something. One of the 6 values has to appear. So this probability is 0. Now we can plug in these values into our formula, and we get that the probability of the union from 1 to 6 of AI equals. So we said the probability of each individual event, AI, is 5 over 6 to the n, and we have 6 of them that we're summing up, so that's 6 times 5 over 6 to the n minus the probability of a pairwise intersection is 4 over 6 to the n. And how many pairwise intersections are there? How many ways are there to select an I and a j out of 6 possible values? 6 choose 2. So we say 6 choose 2 times 4 over 6 to the n plus, looking at triple intersections, how many ways are there to select these indices I, j, k out of 6 possibilities? 6 choose 3. 3 over 6 to the n minus, now quadruple intersections. There are 6 choose 4 ways to select those. And the probability of a quadruple intersection is 2 over 6 to the n. 2 over 6 to the n. And then plus, how many ways are there to select 5 values that the die cannot land on? Well, let's 6 choose 5. And the probability of each such quintuple intersection is 1 over 6 to the n. And we have our answer.